calculus students. Welcome to section 2.4a, the chain rule for derivatives. Today, the chain rule is the rule that we use when we have a composed function. You know the power rule, you know the product rule and the quotient rule. This is the chain rule for composed functions. So in real words, take the derivative of each function separately, one at a time, and only once, in the composed function and multiply derivatives together in a chain. In symbolic form, that would mean when you take the derivative of one function composed with another one inside of it, it equals, you first take the derivative of the outside function, you keep the inside function the same, then you multiply by the derivative of the inside function. And derivative of outside function, keeping inside function the same. Oh, I just said it. Excellent. So this means that if you have a function that is composed of three functions, 1, 2, 3, that you would have 1, 2, 3 derivatives. You would take the function of the derivative of f, the outside function, keeping g composed of h the same. You would then multiply by the derivative of the middle function, keeping h of x, the inside function, the same, times, and the last thing you would do is take the derivative of the inside function. Notice I took the derivative of the outside, the middle, and the inside, 1, 2, and 3. So let's take a look here. Let's try this problem, finding the derivative with the power rule that we know, and then using the chain rule that we just talked about, we should get the same answer. To do the power rule with h of x here, that means that I would first have to square this, x cubed plus 1 multiplied by itself, right? I'm gonna just write that to help myself out. There we go. That would be x to the 6th. On the outside, an x cubed, inside x cubed plus 2x cubed, and then plus 1. There we go. Let's go ahead and take the derivative of this with the power rule we know. That would be 6x to the 5th plus 6x squared. Let's try this with the chain rule we just learned. Okay, so let's first take the derivative. I do have two functions. I have a cubic function and I have a squaring function. The squaring function is on the outside, the cubic function is on the inside. Let me just say that it doesn't matter the order that you take the derivatives in, inside, middle, outside, or the other way around, because when you multiply the derivatives, multiplication is commutative. However, I always do outside to inside to keep everything consistent, so I don't miss anything. So here we go. Let's take the derivative using the chain rule. Okay, I'm first going to take the derivative of the outside function. What I do then is I cover the inside function to not confuse myself. What is the derivative of anything squared? That would bring, I'd bring the exponent out front and reduce the exponent by 1. And what is under my hand, what is my anything, is x cubed plus 1. And we don't need the 1 exponent. Notice I only took the derivative of the squaring function, not of the inside function. Now, let's multiply. We haven't yet taken the derivative of the cubic function. Let's go ahead and do that by using the power rule. That would be 3x squared. There we go. Let's take a look. Let's clean this up a little bit. 2 times 3x squared is 6x squared. Multiply by x cubed plus 1. Let's go ahead and distribute. Notice we get 6x to the 5th plus 6x squared. We get the same answer we did with the power rule. So here's my big blue list of hints. I'm gonna grab a little drink of Diet Coke here. Hints for execution on the chain rule. The real hint is to keep doing it over and over until it's ingrained in you. But A, Not necessary, but I and others take the derivative of the outside function first and work inward. B, only take the derivative of one function at a time and only once. C, cover with your hand or fingers any inside function you are not working on to take the derivative of, like I had done over here. You have, or also cover any function you have already taken the derivative of so you don't feel tempted to do it again. This is an easy form of substitution instead of the text method without confusion or extra work. I also talk myself through the process using the word for anything I've covered. Right, I did here, I said, what is anything squared? D, you are done taking the derivative of the composed function using the chain rule when you have taken the derivative of all the functions, or when you take the derivative of the most inside function if you are using my 4A method at the top. The number of derivatives should equal the number of functions composed total. Okay, E, last one. Just want to point out, when you're taking the derivative of trig functions using the chain rule, the angle will never change for good reason. Because if you are taking the derivative of a trig function, you only take one derivative at a time and the angle stays the same. Okay? At some point, you may take the derivative of the angle as the inside function, but it's being multiplied by the trig function. So let's come on over and let's just do what we just need to do is practice it. Here we go. Number 8, y equals 2, well, you can see what it says, and we're asking for the derivative of y. Notice I have a constant I'll bring along. I have a squaring function inside and a fifth power function on the outside. So here we go, let's take the derivative. Using the chain rule, I keep my 2. I see my fifth power is the outside function, x squared is the inside function. I'm gonna come on this side. I'm gonna take the derivative of anything to the fifth power. That is 5 times anything to the fourth power. That is 5 times anything to the fourth power. Notice I took the derivative of anything to the fifth. I did not take the derivative yet of the inside function. I will now do that with the chain rule. I will multiply, and the derivative of 6 minus x squared is a negative 2x. There we go. I have taken the derivative of everything. Let's clean this up. 10, negative 2, negative 20, x. 6 minus x squared to the fourth is our final answer. Let's do number 12. I'm going to put the book on the floor and take a little seat here. I have a square root function with a linear function on the inside. So I'm going to take the derivative. First of all, notice I'm not putting the derivative symbol. I'm going to have to use the power rule to take the derivative of the square root function, so I'm going to write it rationally and see it. So here we go. Let's take the derivative of the outside function. Anything to the 1/2, the derivative of that is 1/2, and then I reduce the exponent by 1. It's 1/2 with anything to the negative 1/2 power. Here we go. I will now take the derivative of the inside function because I have not yet. Multiply, making a chain. Derivative of 9 minus 4x is negative 4. Let's write this how the AP exam normally would. If this was a free response question, you'd be done, you'd be fine. But this would most likely be multiple choice, and so it usually is simplified better. This 2 cancels out and leaves a negative 2 in the numerator. Notice that this expression is actually in the denominator. That is 9 minus 4x to the 1/2 in the denominator. You're welcome to put the 1/2 or write it radically. There's our final answer. All right, next, we're going to do one like number 24. Go. Number 24. Let's say you have f of x equals x squared times 3x minus 1 cubed. Let's take a close look at this. Notice that when you scan the function f of x, you do see a composed function. This linear function is inside this cubic function, right? But this composed function is only part of the whole function. To take the derivative here, this is actually a product rule with a composed function inside. So I have two rules going on, the product rule and the chain rule. So when I have two rules going on, what I do is I first write what I am going to do. And here's what I mean. I have a product, f of x and g of x. I'm first going to write the product rule, what I am going to do. I am going to take the derivative of x squared multiplied by g, 3x minus 1 cubed, plus I'm going to keep my x squared and multiply it by the derivative of, what I tend to do is when I already have parentheses, use brackets, the derivative of g. There we go. So notice I wrote what I am, going to do. And here we go. Now I'm going to go through again and do it. The derivative of f. The derivative of x squared is 2x times 3x minus 1 cubed, plus I have my x squared. Right now, this derivative then is the chain rule. I see a cubic function on the outside, linear on the inside. So let's first take the derivative of anything cubed. That would be 3 times anything squared. My anything is 3x minus 1 times, I'm now going to take the derivative of the inside function, which is 3. Let's clean this up a little bit. Just keeping the first term the same. The second term, let's see, 3 times 3 times x squared, 9x squared, times 3x minus 1 squared. This was perfectly correct. This is perfectly correct. This isn't normally how it's going to look in the book or on the AP exam. What they're going to do is pull out greatest common factors for good reason. Okay. Notice for a greatest common factor between these two terms, there is an x in common. Notice there is a base 3x minus 1 squared is in each one of these terms, right? So I have already factored this out and I have 1 left from this term. Now let's write what's left. What's left in this term is a 2 and a 3x minus 1 plus what's left in this term here is a 9x. All right, let's clean this up a little bit more. Here's my greatest common factor of x and 3x minus 1 squared. And let's take a look here. Here I have 6x minus 2 plus 9x. Everything is good except for that last term. A little bit of extra work, 15x minus 2. Why will they do this on the AP exam or in your book? Because often we end up setting this derivative equal to 0, so we like it factored so we can set each of the factors equal to 0.
Kitty's checking out calc.
Kidders, what do you think, love? Let's try number 87. Notice, class,
Pretty exciting, huh?
when you are doing this, oops, looks like Fred doesn't want to erase. You have to talk yourself through it, I believe, and be very methodical. Okay, we're not going to be using red anymore. There you go. This is how math teachers end up, like later in life when they're older, just talking to themselves randomly, because we do it all the time when we're doing math.
Well, I didn't tell you the camera's not on, so you have been talking to yourself. No.
Oh my gosh. I would not want to start over. Number 87. Okay, on number 87, they give you a picture. It says, find the equation of the tangent line. Stop immediately. Poor Bill has heard this so many times, right? As soon as you hear the equation of a tangent line, stop.
I give you guys a lot of credit. I still don't know what I'm doing. So
But you're a great fourth
way to
grade
go.
teacher.
Way to go.
Find the equation of the tangent line to the graph at the given point, then use a graphing utility to graph the function in its tangent line. We're, of course, just going to write the tangent line because I know you know how to put these into your calculator. So here's the picture they give you. Here's the 0.34. We're going to use that point as quick as we can. And they tell you that the function for this circle is the square root of 25 minus x squared. Notice, of course, it's a composed function. You have the square root function with a quadratic function underneath. Notice you know that this is the right function for this picture if I drew it better. This is the top half of a circle with a radius of 5, right? We've seen this before, okay? So here we go. With the tangent line, we always do the easy part first and we fill in the point. My C is 3, my f of C is 4. 3, 3, and 4. Class, all we need is the derivative of our function at 3. So let's go ahead. I'm not taking the derivative yet. I am writing the function with a rational exponent. Okay, the outside function is the 1/2 power, the inside is quadratic. Let's use the chain rule. The derivative of anything to the 1/2 power is 1/2 times anything to the negative 1/2 power. My anything is 25 minus x squared. By the chain rule, I remember I haven't yet taken the derivative of the inside function. I'm going to now and multiply it. That's a negative 2x. Okay? Now, I know you feel like you want to clean this up a little bit. You're welcome to. But class, what you should get used to is when you've been given a point, 3, 4, it's much easier to clean up this function when you put the 3 in for x instead of cleaning up the function and doing it later. So let's put in the 3 right now, right here. Let's put in the 3 right here. Let's put in the 3 and let's do some math. Oh, the derivative at 3 now, right? We put it in. Let's see, 25 minus 9 is 16. Now, if this were 16 to the 1/2 power, that would be 4, so it must be 1/4. So we have 1/2 times 1/4 times negative 6. There we go. So we have negative 6/8, which is a negative 3/4. There we go. And we are done writing the equation of our tangent line. Take a look over here, class. If you drew that tangent line, without a doubt, that is a negative slope that you see right there. And apparently it's a negative 3/4. There's number 87. Last one, number 28. Wow, why did I go back and leave 28 for last? I know it sounds like, oh, Miss Culver, you must know why. No, I really don't remember why. Let's go back. Why did I pick number 28? There's gotta be a good, oh yeah, there's a good reason. Oh, class, okay, buckle up. Here we go.
Bill, buckle up.
Buckle up, okay. That's why I left this for last. Okay. All right, class, they're asking you to take the derivative of the function that you see here. Notice that in the denominator, I do see a composed function. I see a square root function with a power of 4 function inside of it. But in general, this is not a composed function. This is a quotient rule with a composed function in it. Because I have 2 rules going on, I'm going to first do the quotient rule and write what I am going to do. Okay, but kids, that's not even the problem. Okay, here we go. So first of all, I'm gonna take the derivative by the quotient rule. That would be the derivative of the numerator times the denominator. Now, if it's okay with you right here, I'm gonna write it rationally instead of radically. Okay, the derivative of the numerator times the denominator minus, I'm gonna keep my numerator and multiply it by the derivative of the denominator. Notice again, I use a bracket. we go, all over the denominator squared. Notice when I square the denominator, the square and the square root cancel out. So that feels better right there. Okay, let's go through a second time and let's take the derivative here and here. Of course, the derivative of x is 1. So I'm just left with x to the 4th plus 4 to the 1/2 minus, I'm going to keep my x. Okay, let's be careful here. Composed function. I'm going, the derivative of anything to the 1/2 power is 1/2 times anything to the negative 1/2 power, right? Reduce that exponent by 1. My anything was x to the 4th plus 4. By the chain rule, I'll take the derivative of the inside function, and that is 4x cubed all over x to the 4th plus 4. Now class, here's the thing. I know when you look at this that you think that these two expressions have a common denominator. They do not. Notice that this term right here is to the negative 1/2. It really is supposed to be in the denominator. These are not common denominators here. So what I'm going to do, are we correct here? Yeah. Is this what it's going to look like? No. Here's what I'm going to do. I'm going to split up these two fractions here and place anything that's supposed to be in the denominator where it belongs. Okay? Here's my first fraction right here. I have x to the 4th plus 4 to the 1/2 in the numerator and x to the 4th plus 4 in the denominator minus, I have a little bit of work I can do here. First of all, notice this 2 cancels out the 4 and leaves a 2. What I do have in this numerator is a x times 2x cubed. So I have a 2x to the 4th, 2x to the 4th. Okay, in the denominator for this term is already an x to the 4th plus 4. And when I bring this expression down, it makes the negative 1/2 exponent positive, meaning that is x to the 4th plus 4 to the 1/2. Now take a look here. When bases are the same and they're being multiplied, you add the exponents. 1 plus 1/2 is 3/2. So watch here. There we go. You can see now that there actually weren't common denominators. What are we going to do now? We're going to get common denominators.
You're using red?
Oh, not using red. Using purple. Thank you, Bill. Using purple. Here we go. Notice that in the denominator, this is x to the 4th plus 4 to the 1st power, right? I am missing an x to the 4th plus 4 to the 1/2 power. Notice if I multiply here, I'll have a common denominator. I'll multiply the top and the bottom. For those of you who are still with me and haven't shut the video off, good for you. Okay, here we go. I now have a common denominator. Oh, thank you. Of x to the 4th plus 4 to the 3/2. All right, let's take a look at our new numerator. I knew this probably, you thought this is going to be awful. No, it's not. Take a look. When bases are the same and they're being multiplied, you add the exponents. Look at that. It's to the 1st power. X to the 4th plus 4 minus 2x to the 4th right here. And this, notice the numerator cleans up very nicely then. What we have is 4 minus 2x to the 4th plus an x to the 4th is a minus x to the 4th. All over, this is absolutely fine. I'm going to write it radically. X to the 4th plus 4. It's being cubed, and we're taking the square root. So why do we do this? We do this because, again, if we were going to set this equal to 0, that would be just where the numerator is 0 because it's a fraction, and now this looks much easier to solve than it did here. Okay, so that took a lot. You may want to watch that again. Now, I just realized Bill has probably had
No,
enough.
you skipped over 58. Is that what you meant?
Yeah, I was wondering where, because I wanted one that had 3 in it. Thank you. Thank goodness you're doing this with me. 58. I'm like, I'm missing. Why would I miss one that would have 3 in it? Number 58, don't worry, class, it's easier than 28. Number 58, let's say that you have g of theta. Again, that very well could have been an x. Don't let the theta throw you. Equals cosine squared of 8 theta. Good, I thought I made a big mistake. Here we go. All right.
That's
We're-
causing problems here.
Yeah.
Okay.
Do you want me just to
Here,
write
let
for
me
the
just
ruler?
stand here.
Oh, okay.
See if
All
that
right.
helps.
Class, take a look here. We have 3 functions, right? We have a squaring function on the outside. How do I know it's on the outside? There's no other function working on it. It is working on this middle function, the cosine function. Inside the cosine function, the final inside function is 8 theta. That's a linear function. If it bothers you, put x's, okay? So this means that when we go to take the derivative, right, we will take the derivative one at a time, outside to inside, and using coverage to help ourselves out. So let's take a look. Outside function was the squaring function. Let's take a look here. The derivative of anything squared is 2 times anything to the first power. My anything is cosine of 8 theta. Okay, 2 things I want to point out here. I only took the derivative of the squaring function. Cosine and 8 theta were the same. Nothing else changed. Notice also, as I hinted down here, when you're taking the derivative of trig functions, the angle never changes, right? That angle did not change this time because I did not take the derivative of it. Let's take now, by the chain rule, the derivative of the middle function, which is cosine. I am going to cover the squaring because I already did it. I am going to cover the 8 theta because it's the inside function. The derivative of cosine of anything is negative sine of anything. And my anything is 8 theta. There we go. Notice again that angle did not change, right? We are down to our last function. We have not taken the derivative of 8 theta. The derivative of 8 theta is 8. There, this is perfectly correct. But what we tend to do is bring our coefficients out front. I have a 2 times 8 times a negative 1, negative 16. I tend to put my trig functions in alphabetical order because it freaks me out to not put them in alphabetical order. And there's your final answer.
Sheldon.
Have a great day, calculus students. Bill, thanks for helping.